draw a sketch. If the sketch isn't there, make sense out of this. Since this is tray, right away, your sketches should be looking like a right triangle somewhere, right? Since these are trade applications. So I gave you this one, and you have an equilateral triangle. The base angles are the same, and B, your base was 8 inches. If you remember back from geometry, this bisector here, this perpendicular bisector, cuts this into 2 congruent parts. So if you look at this, you have a right triangle, and you can find your sides. You can find the altitude, the side, whatever it is you need to find. And what did we have to find? Did it say on yours? The altitude? Okay, so we're missing this piece right here. You've got a tangent going on. You have a right triangle. Make sure you drop your height down there. You got a right triangle. And you've got your opposite and your adjacent sides. Remember, give me 3 decimal places. 3 decimals. Save your rounding to the end. Don't do this first and then put it in your equation and then multiply by 4. Let all your work happen at once at the end. And then you'll find your opposite side here. I said O for opposite. Okay? Stop me if you're not getting this, because this is really important. Aaron?
So whenever it says it just gives you the angle and the side, it has to be equilateral.
It gave you an angle on the side. I don't have the thing in front of me. Was it did it show you that? No. It says find the altitude of an isosceles triangle. The direction said, I don't have the direction on mine, but your directions said find the altitude of an isosceles triangle. This is on yours. An isosceles triangle has 2 congruent sides. The base angles are also congruent. So we drop the altitude, which cuts this in half. And you're going to find that one. So work off of one right triangle. If you want, you can just redo this one like this, if this helps, and you're finding that side. Okay? It says the directions were on yours, not on mine. Draw pictures. The pictures help. Here's an angle of depression. The sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. Now look where the 4,000 is. He's not directly under, he's diagonal. So here's the 4,000 feet on a diagonal. The angle between the water level, here's your water level, and the line of sight for the submarine is an angle of depression. When you move your eyes down, your depression. If we make a triangle like this angle of depression is the same as this angle of elevation. We said this yesterday. We said if we extend these lines, these are parallel lines cut by a transversal, transversal. They are alternate interior angles. So your angle of depression in that case is the same as your angle of elevation. They want to know how deep is the submarine. What is the height that it is to the top? So you have a choice. You could make your triangle here and do the same thing. Use that angle. It's going to be the same triangle as this one. Or drop it this way. It depends which way you would like to make your triangle. It is the same thing. And you're finding the height. So you've got an opposite and a hypotenuse. Either way. An opposite and a hypotenuse. So you're looking at sine. Make sure that your calculator is in degrees. If you come out with a weird answer, or especially if it's negative, don't drop that negative sign. There's a reason. It's probably your calculator is in radians. And when we grade the regions, sometimes kids erase the negative sign because they know it can't be a negative angle, but they go and erase it. Something made you get that. Questions? These are great applications. They send those radio waves that bounce off to see how far down things are. They have to know in terms of their divers and everything else.
So Ms. Moore, you know whether to use sine or cosine or tangent based on what they give you on the side?
On what you have, yes. once you draw your diagram, you'll be able to see which parts of your triangle you have.
Miss Aurora, do you just put it in parentheses,
Like multiplication. Just make sure if you do the sign first that that parentheses is closed.
ma'am?
Okay, check your mode. In degrees.
So we can-
Oh, you want to multiply this. You have an equivalent fraction. Multiply by 4,000. That's your fraction equal sign, so you're multiplying these two. So just multiply that one by 4,000. Okay. The front of an A-frame cottage, so I know it looks like an A, is actually in the shape of an isosceles triangle. And an isosceles triangle has two congruent sides. It stands 28 feet high, there's the altitude, 28 feet high, and 20 feet wide at the base. And again, because it's isosceles, that perpendicular height, that bisector cuts the bottom, the base, into two congruent parts. So again, you're looking at a right triangle, and we can look at just one of these. And you're looking at the angle of elevation, this guy right here. You want to find that angle. So you've got an opposite and an adjacent. When you get to here, you're going to use the inverse tan, second tan, and find your angle. Okay? We find its tangent, we can find the angle. A large part of this, guys, is just the drawing. Get the sketch down pat. If you get your sketch, the rest of it fits into place. Just take it step by step. A-frame, make an A. Isosceles, two equal sides. Two equal sides, two equal base angles. Since it's trig, we're gearing towards a right triangle someplace. Okay. Here's another one. A sign on the roadway at the top of the mountain indicates that for the next 4 miles, the grade is 9.5 degrees. Find the change in elevation for a car descending the 4-mile stretch. So they've got you helped out, they got your triangle here. They're saying here's 4 miles from here to here. You're driving 4 miles from here to here. Your angle of elevation is this guy right here. Here was your horizon. And how far are you elevated like this? So, what's my change in elevation? This is your change. It went from down here to up here. This is your angle of elevation. They just put a little arrow here because they just couldn't fit it in. So you're looking at a triangle that says 9.5 degrees. You've got 4 here, and you need to know the change in elevation from here to here. Right triangle. Anytime you make a height, there's where your right angle comes into play. So, opposite over hypotenuse. Good? And that gives you your sign. And your elevation has to be small. It can't be too steep, right? But you went up almost a little more than half a mile in your elevation from there in the 4 miles that you went. And they say it's not drawn to scale, so it's not exactly like that. Okay? All right? And this one's a big one. This one was like the other one that we did with the 2 tangents. This one was just a little bit tougher. How many of you got this answer? Let me move it so you can see your answer. How many of you got this answer? This?
I think I did it for you.
Yes.
Everything else is the same up until the answer.
You got this? No? Okay. So let's see what we got here. We have an observer in a lighthouse, and the lighthouse is 350 feet above sea level. That's the distance right here. Right here. It observes 2 ships. I'm at the top of my lighthouse, and I observe 1 ship further out, and then another one closer to me. So there's my 2 angle of elevations. Okay, here's my eyesight line. So I've got one triangle that goes like this. And we'll make this over here. And I have another triangle inside. Same distance there. I've got two triangles. They're sharing this height of the lighthouse. So I have one that looks like this, 350, and it uses, but don't forget you can use this as your angle of elevation. This would be your 4, and then you have another one, and this will be your 6.5. Now they want to know how far apart are the ships right here, this distance right here. So if you can find this distance, and then the big one, this distance, can't we then subtract those? Just like we did yesterday, right? So if you work on each one, you want to find its base. I called the one an X, one a Y. So the one with the 6.5 I called a Y. The one with the 4 I called an X. Both of them use tangent. So we set up our tangents. We cross multiplied. Now this was a little different than yesterday, because yesterday when we cross multiplied, it equaled the variable. This time, the y is here. I have to divide both sides to get y by itself. That's the only difference. Yes? You didn't do it? How'd you do it?
I made a cotangent. I put 1 over tangent 6.5 times, you know, the difference.
Oh, okay, you could do that. You flip this around so that you didn't have to do that. Yeah, that was good. That was good seeing that one. That was very good. So that when he multiplied, he didn't have to flip it around. And then we do it for this guy. These are the two pieces that we want. And then we subtract. We just put a subtract sign there. Okay? It's kind of like yesterday. But yesterday, once we cross multiplied, we didn't have to divide because we already had solved for the variable. I'll move this down a little so that you can see it. So you've got two nested triangles. They share the same height. This is your height. We've got this piece, and then we've got this entire piece. And if we subtract them out, we get the difference between them. So we did one for the y, one for the x, and then we subtracted them. Don't subtract until you get all the way down here. Don't put your tangent in and everything. Do it at the very end. If you do put them in, go at least 4 decimal places. If you're going to round to 3, go at least 4. Otherwise, you could throw your rounding off at the end. That was a tough one. But I do kind of like the fact that they helped you by drawing it, because that makes a big difference. Questions? No? Okay. And that was it, right?